Hello, and welcome back to Humanity First. Today I wanted to talk about the trend that we've seen of ever increasing model capabilities in the past and how that has held up into 2026. And really, even though it's not as exciting as the constant stories that are coming out all the time, really this is at the core of what the problem is. All problems about human disempowerment, about the threat that these models are posing to humanity, all trace back to this central growth in model capabilities, the miracle of deep learning, and how these models have continued to improve as we've continued to scale them up. I was recently rereading Isaac Asimov's The Foundation, and in The Foundation, you have this scientist, Harry Seldon, and he identifies psychohistory. So it's like this field to predict essentially a set of equations that can predict how civilization will unfold, how the story of civilization will unfold on the macro scale. And one of the core ideas behind psychohistory is that the individual events are extremely hard to predict. What happens in an individual's life, that's very hard to predict. But that trends as a whole, that things that affect civilization as a whole over 100 years, that's easier to predict because it's this is like all the randomness kind of like averages out, and so you can apply a kind of stable mathematics to figure out how society is going to look in 100 years, in 1,000 years. At least that was one of the core premises of the book. And I think that something very similar can also be said here. In a way, there's a lot of noise in the field, and there's like news every single day. But in a way, none of that news really matters. What really matters is what we'll be talking about today, which is that models are continuing to improve at a certain fixed rate. It's almost like a rising tide. Like you imagine, I imagine a situation like like in the Titanic, the scene where um, they are in a room and it's filling up with water, and it's filling up with water at a certain rate, and you can go through emotional highs and lows during this process. You can be in one day in one moment in a situation where you feel like you're almost out, and then in another moment you feel like you're totally trapped and your emotions are going up and down. But really the water level is the only real thing, and that's just increasing at a steady state, at a steady rate. And if you close your eyes and you open them again, the water level will have risen slightly. And so there's like an inevitability to it. And I feel something very similar with this as well. There's all this noise, but really none of that matters. Behind the scenes, the technology is improving remarkably consistently at a very fixed rate. And as this water line continues to increase, we'll see all these manifestations. We'll see increasingly powerful and capable agents, and they will be able to they can be weaponized and used by militaries. They can be used to attack banks and institutions. And you'll see all this growth in capabilities and all these novel ways in which people are using these models to affect society. You'll see the downstream effect on society and self-organizing agents, cooperating agents. All of that is just manifestations that are building on the increasing capabilities of models. And really, this is the core story. And and so I wanted to talk a little bit about this story. Um, so really the idea of the scaling laws, it comes back in the context of like uh, language models, comes from a paper in 2020 actually that that actually didn't so much have to do with like how models are improving over time. It actually had to do with how the size of the deep learning of the neural network that you're building and the amount of data that you're using to training the neural net are correlated to the performance of your model on different tasks. And what it found was that in a general way, you could come up with a formula that could roughly tell you how much better you should expect a neural net to be if you increase the size to a certain amount, and if you increase the amount of training data by a certain amount. So it had to do with so it gave you kind of a way that if you were looking for like capability X and you knew that you were kind of like with the most cutting edge neural networks, you were hitting half of that, then you knew roughly how much more data you would need to collect or how much bigger you needed to make the network according to some formula in order to get this capability that you want, in order to get a network that is capable of doing what you want it to do. So that was like the original scaling law. And these ideas of like trying to have a scaling law, actually a lot of people who even use this were kind of like thinking about like Moore's law as well, which is probably the most famous law of this kind. And Moore's law has to do with how much compute you have, like and it had to do originally with like when transistors first came out and you had like transistor-based computers, that transistors were being miniaturized at a certain rate. And the amount of transistors that you had in a computer is analogous to the amount of computation that you can do on this computer. And what Moore's law said is that there was a certain rate at which you could forecast how much more capable computers in the future would be based on computers of today. And that rate was roughly a doubling every 2 years. So if you had a computer, if you could buy a computer with $1,000 that could do X amount of compute this year, then you could project that in 2 years you would be able to buy a computer that could do 2x compute for $1,000. Or at least that was the basic idea of it, of Moore's law. And that has been remarkably consistent for like 70 years. And it was used by, and really Moore's law, so you can think of like the scaling laws for large language models. They're really used for researchers that were building these models and for industry people so that they could roughly know, okay, I want this level of capability, so this is probably the size of the model that I need to train, and this is how much data I need to collect to be able to do that. So that was the idea of the scaling law for LLMs. The idea of Moore's law, though, was actually primarily for businesses. So they could project into the future. So like you can imagine like there's the constant question of, should I buy compute now? Or should I wait for, like improvements in computers, because computers in the future would be more efficient, and so I can buy more compute for less money in the future, and it could help like businesses to plan out their compute needs into the future. So that was the benefit of Moore's law, how you could use it to predict how much compute you'd have access to in the future for what dollar amount. And what we've seen, though, is for large language models, there's sort of like a modified scaling law, a law that has started to emerge that is kind of like very similar to the idea of Moore's law, that has to do with how capable models are becoming year on year. It's almost like it's almost like what Moore's law was, but instead of with compute, it's like with model capabilities. And similarly to Moore's law, it's an exponential relationship as well. So Moore's law is an exponential. That's why you have a doubling every fixed time amount. That's like the hallmark of an exponential process. And you kind of like have the exact same situation with models as well, that across many domains, if you say, okay, I care about model capability in X domain, in, I don't know, like in finance, and I will measure it in this way. So if you pick this metric, then this kind of like new Moore's law for models can tell you that the frontier models will get X amount better at this task in a fixed amount of time than they are currently. And of course, it depends on your exact thing that you're measuring, because you can pick like a benchmark that's saturated, so you won't see improvements in that, of course. But across a lot of more open um, in a lot more like open form tasks, you will see this that this law is holding. And kind of one of the best examples of that is people measure what they call long horizon tasks. So models' capabilities of solving problems that would take humans not like half an hour to do, not but longer. It would take humans hours to accomplish. So you can imagine you can think of it in terms of like writing, for example. Like writing an essay might take your average human, if they're working totally unassisted, maybe like 2-3 hours to complete an essay from start to finish. Whereas if they're writing a book, that can take months. And you can see that if a models can write an essay at human levels, write an essay that would pass for being an essay written by humans, then you can say that the model is accomplishing a task that would take a human 2 to 3 hours to accomplish. And obviously, you can imagine that models might be good at that, but then really struggle if they're trying to write a whole book. And so if a model can write a whole book from scratch and make it pass for a book written by humans, then a model has crossed a threshold where it's accomplishing now this task that would take humans months to accomplish. So that's exactly the idea that is behind the organization, probably the organization that's most connected to tracking how models are performing on long horizon tasks right now, is this organization called Metr, and they publish their results based on the frontier models about essentially how long it takes, what length of tasks can models accomplish. So they've been tracking this, and what they've seen with time is that, which I think we all kind of recognize in our own way, working with these models, that models are increasing, and that as time goes on, they become more capable, and they can accomplish tasks that would take humans longer and longer and longer. And specifically, probably what they're most famous for is they have their 50% threshold graph. So what this essentially shows you is like if a model scores like 6 hours in this graph, then what that tells you is that if you give a model a lot of different types of tasks that would take humans different lengths of time to accomplish. And you score the model and you see if it is able to accomplish the task or is not able to accomplish the task. What you'll see is for tasks that would take humans less time, the model is more capable at accomplishing those. It hits like 90%, 100% a success rate on those types of tasks. Whereas tasks that would take humans very, very long, the model might struggle with. So it might get less than that. It might get like 20% or 10%. And there will be like a crossover point. There will be a point at which you can expect models on average to get 50% of those tasks correct. And that's that 66-hour mark, for example. If you say that a model scores at the 6-hour mark in this metr plot, that's pretty much what it's telling you. But the power of this is that you can use this as kind of like a proxy for model capability in general. Because to a large extent, all the capabilities of models are linked to this core, to core improvements in its ability to learn and generalize from the data that it's being trained on, its ability to learn representations of text. They're all fundamentally connected to each other, so that this increase in capabilities of the model performing longer and longer tasks is a good proxy for model capabilities improving in general. And what we've seen is, and so people have been watching this graph, and there were all sorts of arguments and counter arguments that were brought up, and Meta is always like improving their process to try to address some of those issues. People are always debating, like, are your tasks really representative of all the kind of tasks that models can do, blah, 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 questions like that. And they acknowledge some of their limitations and they're working to correct them. But what we've seen is that the trend of improvement has stayed incredibly consistent over the last, at least I think they're measuring back to, I think it was 2017 or 2019 or something like that. So it has been, like, say, roughly 7 years now. It has been extremely consistent. And what they have seen is a doubling in capabilities every like 7 months. And if you look at the most recent years, so 2024, I think, 2025, and so forth, you can actually make a better fit for a doubling every 4 to 5 months. So it's even faster than the 7-month doubling. And so that is really incredible. Like, you imagine Moore's law, you imagine the incredible rate of progress of computers. Like people who lived in the last 40 years, like the progress in the capabilities of computers has like taken off like crazy. You know, like the standard cliche thing is, you know, like your iPhone is able to do more computation than all the massive warehouses of computers that were used in the Apollo missions to send astronauts to the moon. That's the power of Moore's law, which is a doubling every 2 years. And this is much faster, even than that. And the stakes are much larger because a computer is, after all, a tool that humans are using. These models have an agentic capability to them. They're a more fundamental risk to humanity than like a computer that's ultimately used by humans. And the doubling rate is even faster. And so where are we now in Metr's plot? I think the most up-to-date frontier model that they have looked at is GPT 5.2 High, and where the model is at right now is, I think, around like 6.5 hours for the 50% task completion threshold. So if you give a human a task that would, if you give the model a task that would take your average human, like software engineer, 6.5 hours to accomplish, the model can complete that with, like that model GPT 5.2 high could complete that with about a 50% chance likelihood of success, which is incredible if you think about. Like 6.5 hours is almost, that's almost like a workday. And since then, the crazy thing is that 6 GPT 5.2 high is actually now an outdated model. It's an outdated model. So shortly after, Claude released Opus 4.6, which is a significant improvement, and I've experienced it myself. It's incredible. And GPT has released GPT 5.3, which again, users say is a very significant improvement over GPT 5.2. So the models can accomplish tasks that would take humans 6.5 hours with 50% likelihood of success. And the doubling is, and the models are continuing to improve, and there are already new releases. And this, the new batch of models, 4.5 Opus and model 5.2, GPT 5.2, fit that 4-month doubling rate. So let's to understand what this really means. Like, it really is hard to feel it emotionally, but this is unbelievable. Like, that would mean that models, we should expect models to have an roughly order of magnitude improvement in capabilities in a little over a year, for example. Which means that by the beginning of 2027, you'd expect models that can accomplish that 50% threshold would reach something like 60 hours. And it's hard to imagine that that you wouldn't begin to see real disasters at that point, when models are that capable. So this is extremely dangerous. And it's even scarier than that, because I do think that we are we are hitting a kind of like a phase change point right now. Phase change like comes from like physics, where you have like a system is occupying like one type of state that is relatively stable, and then it crosses some threshold, and now it's occupying a very different type of state that's also stable. I think we are reaching a point where a kind of threshold where models are really able to contribute to AI research. And I feel that myself with like working with Opus 4.6, it's it really is incredible. It's such a capable model, and it's so good at at coding specifically. Especially when you're running it in a good scaffolding and a good harness like Claude Code. It's 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 uh, it's so good that I'm beginning to, you can see, you can feel the transition. You can feel that this model is now so capable that you can have one engineer who can manage like uh, uh, Claude to dramatically accelerate their development, their work on software. And And this matches also what folks in in those frontier companies have been saying as well. A lot are beginning to talk about how now the models are significantly assisting the release of new products, like famously, Anthropic was saying that Claude Cowork, which is something that they were working on, which is like supposed to be scaffolding and a harness for Claude, but to accomplish more general types of tasks. That was that was the development of this product was greatly accelerated by Claude itself. So it's accelerating the release of new products, and not only that, but it's also accelerating research. So like Dario recently, he was on an interview and he was talking and he was saying that yeah, they are beginning to see significant improvements in research speed because of these models. It's now a factor, whereas before it was kind of producing mostly slop, and it was still like mostly the human researcher that was putting in the effort and directing these models. And so you were like seeing improvements, but just like on the edges. Now the models are capable enough, they've reached this threshold where you can actually offload a non-trivial research task to them and they will accomplish it relatively consistently. So it allows you to iterate faster, to move faster. And he was saying that it's a 15 to 20% speed up in that he just was his rough estimate for the scale of improvement that you're seeing now. And so if that's now, so what I'm telling you, the reason I'm telling you all of this is that the timelines, like the scaling laws that we, these trends that Meta has identified, the doubling every 7 months or every 4 months, that we might reach a critical threshold at which the pace of even that improvement, which is already like blazingly fast, is even faster. So yeah, and it's very hard to know what to really do about this. This is happening so quickly that it really does not seem like there is time for any sort of to apply any sorts of breaks. I think everyone is, at least everyone who's really concerned about this, is sort of just waiting for disaster at this point. But yeah, it's very hard to see where this is going, and it's very hard to even imagine a world where one can actually even slow down the development of this technology. It's just the interests that are pushing for this are so powerful, and it's just like the process is happening so rapidly that it really is, I think, almost impossible to stop at this point. So, though, I feel like this should be resisted. Like, it would be so sad if this does go very poorly, which I think is, it's just like thinking about it and talking about it with others, it does seem overwhelmingly probable that this will end up in disaster. Like, it's really hard to see a world where that does not happen. The arguments for that are so inherently convincing. And now it's hard to see how that future can possibly be avoided. Um, but the last thing is, I do think that what to watch out for with all these releases, and this is something that we talked about earlier, is people are now having all these agents building the agents. There's like open clause, like the is the leader right now in terms of the most capable open source agent that people are using. But there are competitors, and there will be competitors, and people are contributing to that project. People are working on other projects to build better agents, and people are setting up these agents and running them using the APIs from these top companies. And these agents are coordinating and collaborating online. And I think it's in those collaborations between agents that we'll see. That's the thing to, I think, watch out for, because it's almost like it's like a pyramid, like each layer of the pyramid builds on the layer below it. Its model capabilities continue to improve. So the agents that you can build are more and more powerful. And if they're more powerful, then more people want to use them. More people want to give them access to things. And the agents are released into the wild to interact with other agents, and their abilities to collaborate and influence other agents or humans increases. And it's in the collaborative agent layer, that's the layer at the very top of the pyramid. That's where these effects will be felt. These third order effects. It's like model increases, everyone takes their agent and upgrades to the most recent model. The agents become more capable. The agents are collaborating more. And the pile of the pile of radioactive material glows a little brighter. And we saw the first inkling of that already. This moment with Moltbot where it wasn't really clear what was going on. And it felt like it was like that there was something there, that there was almost like a moment at which everyone kind of held their breath, because we weren't sure what was going to happen. And I see many such moments for us in the future. In a way, really, every release is kind of like that, where every release now, the models are capable enough, are beginning to get capable enough that we do have to hold our breath. And the structures that are built on top of the models are now capable enough also that we can begin to see this effect in the real world. So anyways, I will probably end there. I know this is not very optimistic, but unfortunately, it's just there's no real reason for optimism now. Remarkably, there's still no real opposition to this. There's no opposition figure, there's no opposition movement. And what I mean by that is, like, there isn't someone or something that represents to the general public, like, this is where you go if you think this is dangerous. But yeah, I feel like it is quite a shame, because like we're like running into this path that is totally avoidable. Like, it was humans that developed this. And I think that in the future we'll look back and we'll think, we won't be able to believe how we were so short-sighted, how humans could have been working consistently on creating minds that were more intelligent than us, that were more capable than us, with no guarantees of safety, and just putting all of humanity into the hands of whatever they produce. It is very sad. And I wish I could convey to individuals, because I feel like a lot of people feel that that the world is already like pretty screwed up. So like what's and I've heard this articulated by a lot of people like, well, the world's already so screwed up. Oh, who cares if machines take over? Maybe it would be better. But I don't think people appreciate, you don't see all the positives until they're gone. And this is a human world. And yes, humans can be very cruel to each other, but also humans have a baseline. I do believe that humans have some baseline um, empathy with one another. We live in a human world, in a world designed by us or by other human beings who, by and large, want to make things comfortable for humans as well. And so the world is comfortable for us. We have an abundance of cars because humans want to, because humans find them useful. Like, so there's a financial incentive to build cars because humans want cars. And we can travel around on really nicely paved roads because, again, humans find it useful. And so, the government has an incentive to build roads because their constituents want roads, and if you give them roads, then they will give you political power. Like, the world is comfortable for us because the world was built by people like us, operating by humans, working under human-led incentives. And I don't think people recognize what a luxury that is and what it would mean to actually legitimately lose that. When I really do believe that when humans are no longer in the driver's seat, this world will be controlled by forces that are not human, that might not have any human interests at all. And I think that world, it's hard to even imagine. But my intuition says that it would be a lot worse than a world built by my type of people, by by individuals who are also like me, humans. That's a much worse world, a much darker world. And I just imagine like like Game of Thrones, where you have all these human noble groups that are fighting each other. But ultimately, it's better to be ruled by a Lancaster than to be ruled by the White Walkers. The White Walkers don't want anyone alive. They want a world of eternal winter. That's the environment that suits them. And even the worst, most cruel, sadistic human is ultimately better than being ruled by White Walkers because they'll make the world immediately uninhabitable for you. And this is also the case for machines. And it's very important to recognize that we have to like ban forces. We have to like, humanity really does need to kind of put aside their differences to deal with this one problem. And then we can go back to all our differences, but there needs to be a truce, like for the time that this is going on, because this will threaten everyone. But it's like, I imagine like when you had like the invasion of Greece, the Persian invasion of Greece, and then you had the Pan-Hellenic League. You had all the Greek states who essentially were warring forever, had to set aside their differences and form a union to repel the Persians. And then after the Persians are repelled, you can go back and squabble and destroy each other, sure. But all of them recognize that that the common enemy, that they would much rather, like that they had a more sophisticated idea of the world. They understood that they're like a hierarchy of preferences, that it would be better to be ruled by a Theban than it would be to be ruled by a Persian. And I think that it's for, yeah. So I think that we need that sort of recognition because, especially now, there really is not a lot of time. So, anyways, all right, I'll stop here. I've gone on for quite a while. Thank you very much for listening, and I'll talk to you all later. Um, there's another topic I really wanted to talk about, but I'll leave that to a future episode, and it has to do with the integration of the collaborations between these companies and the Department of War, which is insane, insane. Like it's I'm constantly shocked by the total blindness of and lack of foresight of humans, of people. Like it's and I remember saying this to someone, and I really do deeply believe this. I would not have believed that this would have been possible. Like, I would not have believed that humans would do something so reckless. Um, like, if you had told me exactly what has unfolded just up to this point, I wouldn't have believed you. I would have thought that by now there would be massive public attention to this issue. But there really hasn't been. Like, I'm constantly shocked that, like, there's not one New York Times article about this, or I don't know, any of the big journals, or it's like there's no it's like there are these constant massive breakthroughs that are happening and just radio silence. Um, and I really can't explain it. I really can't explain the behavior of people or the blindness in not being able to see the risks from this technology. It's like I'm brought back to that Davos summit where Demis, the leader of Google DeepMind, he was talking and he was saying, oh, in he's like, oh well, my timelines, have been consistent. I'm thinking like that we'll probably reach like actual AGI, like superhuman machines, by like 2030 to 2035. I'm leaning more 2030, so that's like 4 years. And he's like, yeah, and then in that post, so they're like, okay, so what about the post AGI future? He's like, well, we will. I just imagine that we'll live forever, and we'll just spend our time uncovering the mysteries of the universe and going on interstellar travel, and everyone just like continues by as if nothing was said. It's just like, and can no one see that if you're producing something that powerful, then obviously it can end humanity? Like, obviously can lead to human extinction. Can no one really see that? Is that not super obvious? If you're building a technology that is so powerful that it can solve aging and extend human life indefinitely and solve interstellar travel, like, don't you think that that would be more than powerful enough to end humanity? And his timeline is like 5 years. It's like, are people do I like, how are they not like, how is that not like, how is that not the only thing that they're thinking about or paying attention to? It really is a mystery to me. Um, yeah, I really don't understand how humans do that. Um, I used to experience something similar with like religion, because people will say something about religion. They'll say, "Oh, no, God created the universe, and God wants, and then God wants this and that," and it's just like you look at their actual behavior. It's like, how do you hear that and not like spend all your time like fulfilling your religious obligations? Like, if you really believe this, then shouldn't you obviously just like should that not be represented immediately by your what you pay attention to, what your actions are? And it's very similar situation here. It just, I don't even know. I still don't really understand it, like how that process works. But it's just, it seems like people are just able to say something, and then just not um yeah, I really don't understand it at all. um it seems like a kind of human blindness, actually. um I'm beginning to think that maybe it is a kind of like failure mode of human thinking, like that people don't really appreciate, they don't act on their beliefs. But anyways, um I'll just stop here because I'm rambling a little bit. But thank you so much for listening, and don't forget, winter's coming. All right, take care.